and welcome back to another video. This video introduces interfaces and how we can leverage them to rely on composition over implementation in Go. So in this video, we're going to be covering interfaces for those who are new to programming, kind of describe the concept and what their purpose is. Then we'll define and implement an interface, compare them in Go, how they are in Java and C#, and then we'll give a more concrete example of a better use case of interfaces. So if you're looking to take the next step in your programming journey, then covering interfaces is that next step. Much of what you'll be doing when you start connecting to APIs, defining quote unquote contracts between services in programming will be done through interfaces. And actually, several of Go's standard libraries already rely on interfaces and not concrete implementations. But before we get into interfaces, let's separate the distinction between an interface and a concrete implementation. At a high level, an interface allows a user to perform some sort of action without knowing all the details that it takes to do that action. So when I think of interfaces, I think of a TV remote. When I want to turn the volume up on the TV, I hit a button on the remote and the volume goes up. I don't care how the volume goes up on the TV. I just care that the volume increases. And we can see that this is an interface because if you've owned a TV in the past and let's say the original remote broke or you lost it or something, you can always go to your local store, buy another remote that says it's universal or something, bring it home, and then you'll see that this new remote works with your TV. And it's because it conforms to some sort of standard interface that your TV requires to change the channel, turn the volume up and down, so on and so forth. So the interface is defined by the TV, and the concrete implementation in this case is the remote. The remote is doing the physical action of at least sending the signal to turn up the volume. And then the TV itself is also doing some sort of behind the scenes work to increase that volume for you too. And with that distinction, that leads us to the same thing in programming. A programming interface defines a set of desired actions and results without holding the client or the caller to a specific implementation of it. So let's see how this looks like in a coding example. To explain the idea of what we'll do here is we'll create a program that allows users or my friends to travel from New York to LA. Now, one friend says that they want to drive, and as you can see, that's a very long drive and plenty of construction that they have to go through, and it's going to take them 2,700 plus miles in over 41 hours. Let's say I have another friend that says, oh, you know what? I want to take a bus and travel across the country. Well, that's going to take them 2 days and 20 hours and a bunch of different buses. Let's say another friend is feeling very adventurous and they want to walk. That is going to take them 1,016 hours and quite a lot of elevation changes, especially as they go across the middle of the United States. And lastly, we have one friend that says, you know what, I have enough money, I'm just going to fly from New York to LA, and it's only going to take me roughly 6 hours and an extra $170. So that's the idea that we're going to kind of implement in our program. All right. In our code, we're going to create a series of structs representing the various ways that we can travel. So we'll start with car. I'll have type car, which is a struct, and we're not going to really have anything in it, but what we will do is we'll create a method that belongs to the car struct that will make it travel. So I will define a func that is on car, and since it is just reading, or it's not even really doing anything with an instance of a struct, we can just use the value receiver. So we'll say ccar, and then the method will be called travel. And all it's going to do is do a format.println. So we have to import FMT. And down here, we just do println traveling for, what was it? I think it was 41 hours. And we'll actually say driving just to make sure we're driving a car here. So here's our car struct. We have one friend that's going to be driving for 41 hours. And remember, we had another friend that said that they want to instead fly. So here we'll just create another type. So type plane, which is a struct. We'll just open up those braces and then we'll copy this function and just replace it with the plane. So p plane. And when a plane travels from New York to LA, I believe it was 5 or 6 hours, we'll go with 6 hours. So flying for 6 hours. And so you can start to see a pattern here. We get some sort of struct, and all these structs that we have so far have some sort of travel function, and it's performing the same action, or it's producing the same end result. You're going from New York to LA, or in this case, we're not even saying you're going anywhere, but driving or traveling for some amount of time. So this is sort of conforming to an interface that we have. So let's go ahead and define what an interface looks like in Go. To define an interface in Go, it's similar to the struct. You just do type, and then we give the name of the interface. Now, idiomatically in Go, interfaces are appended with the ER postfix. So if I wanted to, we have reader and writer interfaces in Go. And so for this, we'll have traveler, and it's an interface. And within the interface declaration that we've created here, you define all of the functions that the consumers must have. So here, I say that I will just want every traveler conformer to have some sort of travel function. Has to be called travel with the capital T, must take no arguments into it, and then therefore they will conform to the traveler interface. Now, if you come from Java or C#, you would think, okay, now I have to go back to my car struct or objects that you have, and I have to update them with implements, or I have to have some sort of keyword in their declarations. But no, you don't in Go. In Go, the car struct and the plane struct already conform to this interface. You don't have to worry about saying this implements such and such interface. So let's prove this, that these now conform to a traveler interface. But first, we haven't even created a plane or a car to prove that they're printing the correct things. So let's create a var called car, and it will be equal to a new car, which I can take out the var part there. And then here I can say car.travel. We'll go ahead and create a plane similarly. So plane is that, and then we can call plane.travel. I can save this. Let's go ahead and run this. And we get driving for 41 hours and flying for 6 hours, respectively, of when we decide to travel. All right, so that works. But the whole point of interfaces is that we can swap out implementations. So let's do that in code too. So here I'm going to say I have some sort of variable, and it's going to be a mode of transportation. Mode of transport is what we'll go with, and it will be of type traveler. This is saying that I'm going to have some sort of variable here that conforms to the traveler interface. I don't know what it is, but all I know is that I can call the travel function. So here it is, and we're going to go ahead and assign it a car. So I'll say mode of transport is going to be equal to a car. So now I can call mode of transport.travel, and let's see what happens. So here, let's remove all that, do another go run, and we get driving for 41 hours. It's almost like it's magic. We put in some sort of implementation that we had from somewhere else. Now, our mode of transport doesn't have to stay as a car either. We can always change it. So right below this, we'll just copy that line, make it a new plane, and then call mode of transport travel once again. And when we go to run this, we get driving for 41 hours, because that's what we originally called it as when it was a car. Then we switched it to a plane, traveled again, and flew for 6 hours. Now, hopefully you're starting to get the idea. We don't have to just leave this as hard-coded values in some sort of function either. We can accept interfaces through our functions. So here I will do a func called custom travel that accepts a t that is of type traveler. And here it'll just call t.travel. So now I can just call, or let's first create a car again. So we'll just say car is equal to a new car. And then we can now call custom travel, pass in the car. And when we go to run this, we get driving for 41 hours again. So I hope you're starting to get the bigger idea here, is that we can now define some set of rules or actions that we want performed, but we don't quite care about how they're taken action on. It's just that we want a particular result. Now, this is quite a trivial example that we have here. We're just assuming that we have a couple structs, and those structs will only have one method associated with them that happen to be named the same thing. But in the reality of programming, that's not how it always works. If we're traveling in a car, then at some point we're gonna have to stop for gas. So here, let's create another function that's on car, so C car, and it'll be called get gas. And we'll just do a quick print line saying getting gas. And so now when we go down here in our main function, if we go back to what we had before, where we just had a mode of transportation, so var mode of transport, it will be a traveler, and then we assign mode of transport to a car. You would hope that you could call the get gas, right? But that's not quite possible. So I do mode of transport and I cannot call get gas. It's a compiler error because not all travelers have the get gas method associated with them. So you may wonder, okay, well, there's going to be certain times in my program where I know I'm going to have a car mode of transport and I want to be able to call get gas. Well, there's a little bit of a workaround and we can still do that. And let me show you. If we want to be able to call extra methods on a particular type when it comes to interfaces, we must do what is called a type assertion, where you do the variable that you have, dot, and then the type that it is, and then you call the function. It basically reads that you know that the variable is currently that type in the program, and that you can call its other methods. If it's not that type, you'll not be able to call that function and would therefore be a compile time error. So let's do a type assertion. So I want to assert that when I am driving a car that I can go ahead and get gas. If you remember from an earlier video, we can do the if okay idiom. So if value okay is equal to, and so now we're going to give the variable that we're trying to work with here. So mode of transport, and then dot, and then now we pass in the type that we hope that it is. So here it'd be car, and then here I will say not okay. Then we can print out cannot call get gas. Otherwise, we can say val.getGas. So let's break this down again. So mode of transport.car, given this type, this is going to return to us two values. It's going to return us the value if it happens to be of the car type, if mode of transport is, and if this was an okay conversion. So we first check if this was not an okay conversion, then we should not access value. Then we're going to print cannot call get gas. But if it happens to be a car and it was a successful conversion, then we can go ahead and say val.getGas. Let's go ahead and run this to make sure that this all works well. So go run, and it says getting gas. Now, instead of this being a car, let's change this to a plane. And what you'll see here is that that was a very quick and simple code change. And that's the whole point of interfaces and programming too, is that instead of having to rewrite a bunch of different things, you just do a quick swap with a different implementation. So here, now we have a plane, and obviously a plane is not a car, so this not okay is going to run. So when I do go run, it says cannot call get gas. So in this instance, we'd probably have to do going to airport for layover or something. And so that's the basic idea of interfaces in Go. Alright, so if you've made it this far in the video, then I sure hope you've learned something. And if you did, I hope that you would give this video a like and you would subscribe so we can continue to produce more of these. I hope you enjoyed, and I'll see you in the next one.